So many of you guys have been emailing me, telling me you're having a hard time writing the equation for your trig function, especially how to identify the period when you're given a word problem. So I think it's important for us to pause for a second and let's remind ourselves and review the basic sine and cosine functions, as well as the negative sine and negative cosine functions and what they look like. So I'm going to graph the sine function in blue. I will graph the cosine function in red, and then I'll graph the negative sine function in orange, and I'll graph the negative cosine function in green. So before we graph them, let's just remind ourselves of the period for sine and cosine. So for sine and cosine, we get one full rotation, so that means the period, right up here, the period or one full rotation of sine and cosine that happens over 2 pi. So what I'm going to do in this graph is I'm going to label the x-axis from 0 to 2 pi, and I'm going to divide 2 pi into quarters. So halfway is pi, a quarter of the way is pi over 2, 3/4 of the way, that's 3 pi over 2. And then on the y-axis, I'm going to mark +1 and -1 because that's the range for all sine and cosine functions. Now let's focus on that sine function. We know that when we take sine of 0, so off to the right-hand side here, when I take sine of 0, the output is 0, so I can plot that point. When I take sine of pi over 2, that output is +1, so I can mark that point here on my graph. When I take sine of pi is equal to 0, so I can label that point. When I take sine of 3 pi over 2, that gives me 0. Or excuse me, that doesn't give me 0. That gives me -1. So I can mark that on the graph here. And then sine of 2 pi, that puts me back at 0. So I can mark that last point. So if I connect these points with a curve, you can see that positive sign. So that's the graph of positive sine. It looks like an S or a snake. You can think of it as a snake. And there's no shifting here for this sine function. Now let's do the same thing for cosine. What does cosine look like? So again, cosine of 0 is always +1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And then cosine of 2 pi, we go back to that maximum value of 1, and that completes one full cycle of positive cosine. So I hope you can see that positive cosine functions with no shifting, it always looks like that upside down U, okay? Now let's focus on what negative sine looks like. So we know what positive sine looks like, it's that blue graph. But negative sine, take all those outputs, so 0, 1, 0, -1, and 0, and look at its inverse. So I'm going to graph negative sine in orange. So negative sine of 0, we still get 0. Negative sine of pi over 2, instead of getting +1, we're going to get -1. Negative sine of pi is also still 0. Negative sine of 3 pi over 2, instead of hitting a minimum at -1, I'm going to hit a maximum at +1. And then negative sine of 2 pi is 0. So when I connect all the orange points, you can see that that orange line is the graph of negative sine. So it kind of looks like positive sine, but then it's flipped over the x-axis. Okay, so keep in mind what these graphs look like in your head, okay? And then let's go ahead and graph the last function, negative cosine. So negative cosine of 0, instead of hitting a maximum at +1, we're going to hit a minimum at -1. Negative cosine of pi over 2 is going to be 0, right? Negative cosine of pi, instead of hitting a minimum at -1, I'm going to hit a maximum at +1. Negative cosine of 3 pi over 2 is 0, and then negative cosine of 2 pi, instead of hitting a maximum point at +1, I'm going to hit a minimum point at -1. So when I trace that negative cosine function, hopefully you can see that it looks like that red curve for positive cosine, but again, it's flipped over the x-axis. And so I know right now when you stare at this graph, it just looks like a whole bunch of squiggly lines, right? But again, just focus on the shape. So I'll use a highlighter to trace positive sine. So positive sine always looks like that S, okay, where we start at the midline and then we hit a maximum and then we go back to the midline, minimum, and then back to the midline. Okay, I'm going to highlight the positive cosine. Well, actually, let me do the positive. Okay, so we just graphed positive sign. Let me highlight negative sign. So negative sign is that orange graph. So again, here, take a look. We start at the midline, and then we hit a minimum point, back to the midline, maximum point, and then back to the midline. Okay, for negative cosine, or excuse me, for positive cosine, it's that red graph. So we hit a maximum, and then a minimum and a maximum. So it looks like that nice smiley face, okay, or the U. And then if we graph and highlight negative cosine, then it kind of looks like an upside down U. Okay, so there you go. Okay, so how does this apply to a word problem? Let's take a look at an example like your homework question from section 2.4, question like number 8. So in this particular problem, we're told that the pressure for a pipe oscillates, right, from low to high. So again, just make a quick sketch of an XY axis here so that you can visualize the problem. In this particular problem, X represents time, where time is measured in minutes. And then the Y axis, this represents the pressure, okay? And it's the pressure of the pipe, and it's measured in pounds per square feet. So we're told that the pressure goes from a low to a high, and for my particular problem, my low is 110 pounds per square foot and a high of 250 pounds per square foot. So that's all I really need to label on the y-axis. I'm also told in the problem that 3 times an hour, the pressure oscillates from a low of 110 to a high of 250, and then back to a low of 110. So if every 3 times an hour, so that means that if I take an hour and divide it into thirds, right? So let's take an hour, which is 60 minutes, right? Divide it by thirds. That means every 20 minutes, right, I complete one full rotation going from low to high back to low. So right away, this tells me that this must be the period. Okay, so I can mark that on my graph. So at t equals 0, I'm told in the problem I hit a low, right? And then every 20 minutes, I complete one full cycle from low to high, back to low. So that means that halfway between 0 and 20 minutes, which means at 10 minutes, okay, I must hit a high. And so here you can see that if I sketch this graph, what does that look like? So here, this is where you take a look at your graph and you go, what shape is that? And I hope that you guys can see that here, this shape is the shape of negative cosine. So that's negative cosine, no shifting. That's really important because that's going to help you write your equation. So off to the side here, I know my period. I know I have a negative cosine function. So I need negative cosine of x, no shifting. And then the other thing that I need is I need to calculate my amplitude. I need to calculate my midline. And I also need to calculate my k value. And so remember your k value, that's 2 pi over your period. So here, that's 2 pi over 20 minutes, which gives me a k value of pi over 10. So I need that piece of information. And then to calculate my midline is just 110 plus 250, divide that by 2. That gives me a midline of 180. So 180, that's my midline. Okay, and then my amplitude, well, my amplitude is going to be, I'm going to start with my maximum number, subtract my midline. That gives me an amplitude of 70. So I have all the pieces to write my equation. So down at the bottom here, I can write the equation for this function. So here, the pressure, right? I've got negative cosine, so I'm going to go ahead and write that negative sign, and then write down the amplitude, 70, right, times cosine, and then your k value, which is pi over 10, times x, plus my midline of 180. So now I've got the equation of my line. I hope you can see how drawing a sketch, so making a sketch of the graph, so this portion here, this really helps you visualize the problem. And then again, you have to go back and ask yourself, right? Once I make a sketch of that graph, what does my graph look like? Does it look like positive sign or negative sign? Does it look like positive cosine or negative cosine? And that helps you determine how to write the function. I hope this helps.